So the goal of my talk today is to give an overview of some challenges and applications raised by reasoning on data. So as we all know, data are everywhere. They are multi-form, multi-source, multi-scale, and they are the impact to bring very valuable insights to help humans to take decisions, make diagnosis, plan action, do prediction, and more interesting, complicated tasks. So reasoning on data is a branch of so-called symbolic AI, which covers several approaches that are all based on some explicit logic-based models that are processed by generic reasoning algorithms. This is in contrast with numerical approaches that are based on data embedding and numerical techniques that infer, that predict answers based on training the system on a huge amount of examples provided as labeled data. So at the moment, numerical data-driven approaches are more visible due mainly to the success of deep learning approaches for pattern recognition tasks applied to images or text. These approaches are even presented as modern AI and symbolic AI being considered as good old-fashioned AI, GoFi. And in fact, these two approaches, and it is presented as a good old-fashioned AI, mainly because they are considered as less robust and less scalable. They are less robust and less scalable than these approaches for several reasons. The first reason is that the rules that are correspond to the logic base, usually given as logical rules, have to be hand-coded. And the second reason is that the generic reasoning algorithm usually have a high computational complexity, at least in the worst case. So for the first point, I want to emphasize that more and more work exists on learning rules, automatic learning rules from data. So I think that this is not a drawback anymore. In fact, these two approaches have their own advantages and disadvantages. And the counterpart of